Hello, everybody. Welcome to our webinar today. My name is Amissa. I'm the Director of Engagement here at Uptime Solutions, and we're so happy that you all could join us for our webinar that is titled Bridging the Divide, Closing the Gap Between Reliability and Condition Monitoring. I'm joined here by Matt. He's going to be our featured expert speaker. We'll learn a little bit more about him soon. But before we jump into the webinar, I want to give people a little bit of time to join. I see we already have several people who have joined us, so thank you guys for being on time. I'm going to go over a couple housekeeping things for the webinar. So one, we have the chat. It is a little chat icon that looks similar to the one on the slide there. In that chat, you can make comments, add commentary to anything you're hearing. You can ask questions. Really, it's meant to be a way for all of us to be able to engage with each other during the webinar. And then also there's a little Q&A question mark icon that you can utilize during the webinar if you have a burning question or something that you really would love answered by Matt. Type the question in there, and that makes sure that I don't miss it. And then at the end, we are going to have some time for Q&A where we will address any questions you guys have asked there. So just to make sure you guys can find the chat and know how to interact in the chat, if you feel so inclined, why don't you put where you are joining us from today? And while we're waiting for people to do that, I'm joining from Oregon. And Matt, where are you at?
I'm joining from Waupaca, Wisconsin.
Wisconsin. Okay. So, oh, we got quite a few different places.
Yeah, I like it.
Raleigh,
UK,
Alabama,
got some
New
reliability friends in
Jersey.
the UK. I like it.
Nice. Awesome. Well, thank you guys for chiming in. I see that we still have more people joining, but we'll go ahead and dive into today's webinar. Next slide, please, Matt. Oh, look who it is. It's Matt. So I would love to introduce our featured expert speaker today. Matt, please introduce yourself. Tell us a little bit about your background and
Sure.
what you've done in this industry.
Well, thanks, Amissa. Hey, everyone. It's good to be back here again. I know Amissa and I are very excited. We love doing these things. It's been a few months since we had a chance to get together here, and I see we have a packed house, which is great. I see a lot of just looking at the list here, everybody's saying hello. We got a lot of new faces along with a lot of familiar faces that join us, friends from industry. So again, my name is Matt Knuth. I'm the VP of Reliability here at Uptime Solutions. I've been heavily involved, for those of you that don't know me, I've been heavily involved in condition monitoring, asset reliability, and industrial equipment repair since way back in 1998. In that time, I've had the pleasure of working with hundreds of major manufacturing and mission critical facilities globally to improve their operations. Missa and I are very excited to be here today with you all and really hope you gain some good insight into the world of condition monitoring and asset reliability, and most importantly, how to successfully have them work together.
Thanks, Matt. So quickly, I'll cover the agenda. So Matt's going to go over why reliability gaps exist between condition monitoring and then action that's being taken. He's going to talk about quantifying failure and measuring performance. He's going to talk about some of the metrics that you use to do that. He's really going to talk about the actionable steps you can take in connecting your reliability to your condition monitoring data and the information you're getting. And then he's going to touch on at the end having a proactive reliability culture, which is really what brings all of this together and into focus. And then at the end, we'll have a little closing information and some Q&A that we'll go over as well. So Matt, I will kick it over to you to dive into the webinar.
Sounds good. Thanks, Amissa.
Mhm.
So again, those of you who know me or have been into any of my sessions over the years know I always start with this slide. I think it's a very important slide. I think we've all dealt with this at one point or another in our careers. It's often referred to as the most expensive sentence in our language. This mentality ultimately creates a gap between our departments that not only erodes plant reliability and uptime, but also fundamentally, excuse me, limits the success of our each of our individual teams. And that's what we're going to address today. So with that, let's start by I'll start off with the ugly, and we'll work to the solution. So we'll start by looking at some ugly statistics here that I'm going to throw up that I personally believe heavily impact are heavily impacted by the things that we will be discussing today. So I'm not gonna read through all, what do I got up here? 8 of these things. These are not statistics that I just pulled out of thin air. These are uh, widely accepted statistics throughout industry that still hold true today and have been for quite a while, unfortunately. So with that being said, I'll ask you this question. I'll start off with this question. What's the opposite and equally as dangerous as the first slide that we looked at? We have always done it this way, and it's this, what we call the innovation trap. Now, I got to throw props out to our good friend Trent McJunkin, who so kindly allowed me to take this slide from one of his presentations that we did together when we were down in South Carolina this spring. But I think he really hits it home on this, pursuing the next big thing. If you look at what he had written there, why improvements die quietly, Trent says you cannot build improvement on top of survival. Initiative fatigue sets in when the first emergency causes the new checklist to be skipped. And I think we've all dealt with this at one time or another. And I think his picture here is it's both comical and sad at the same time, right? We've seen this the next big thing. As you can see there, the gravestones: 2020 TPM, 2022 5S, 2024 Lean Six. What's the next thing? And we're going to get into why this happens. So let's take a look at what I believe are some of the key factors contributing to this, these figures, and ending us up in this innovation trap cycle, and then ultimately how to get out of that. So here are 4 key factors that I believe are creating the gap. They're not in any order of importance, and let's be honest, for those who joined us today, you could probably think of another half a dozen or so to add to this list, but unfortunately, we don't have 3 days to go over this. So I'm gonna unpack these 4 issues, and then we'll discuss the solutions. So briefly here, lack of communication, operating silos. We're going to talk about leadership, or I should say the lack thereof, lack of cross-functional teams, and the lack of documented processes. So starting off with communication breakdown, right? We're just going to run through these parts here quickly. You guys, Amissa, remind me, I think they'll have access to this to like PowerPoints or whatever. We'll send that out in like a PDF or something afterwards. So you guys will be able to digest this a little more in your own time too. But silos obstruct the critical exchange of cross-functional data, right? And innovative ideas. Another thing we've been hearing a lot of folks talk about this year, and it's a good topic, is role ambiguity, misunderstanding of departmental responsibilities regarding asset health, stagnant reliability practices, leading to degraded decision making, inefficient resource allocation, and most of all, and most importantly, I think, where those top 5 points lead us to is the reactive cycle, right? Which ultimately puts us, the lack of shared information traps that organization in what we like to say find and fix mode, rather a loop of that rather than a proactive state. The biggest thing with poor leadership, and I think many of you will agree, is that when our leadership has a lack of vision or a lack of goals, we revert back to that slide that I started with, that teams revert to survival mode rather than pursue strategic reliability. And that's simply because there's just not the time to pursue that, right? When we're constantly in firefighting mode. Organizational misalignment, simply departments then just start moving away, moving in different directions without any kind of unifying objective. Again, leading to the erosion of trust, right? Success becomes a moving target. And let's be honest, we've probably all been in a place in our careers where moving targets were a thing. And let's be honest, moving targets equal no fun, massive stress, and quite honestly, they're not obtainable, right? They're just unobtainable. Resource constraints, well, this is a biggie. Failure to secure the tools, training, and personnel necessary for success. Um, when we don't have that, things collapse very quickly. And ultimately, leading to the last bullet point on this slide is talent attrition, which I'm going to touch on quite a bit throughout this webinar. So, difficulty retaining skilled professionals in critical reliability roles. We hear a lot about, for several years now, the lack of skilled trades, but I think that's coming back. I think, the money's there, the want is there, the technology is there, it's appealing, but I think it's now moved to where the hardest thing is actually keeping employees. So breaking the functional divide, I like to call this the collaboration gap. So without cross-functional coordination, departments drift into misaligned priorities, right? Conflicting timelines, disparate goals. Moving down the line there, you see the perception trap, a lack of mutual understanding, right? And what that is, case in point, below that is reliability engineering, as I say, may be viewed as purely theoretical, where us condition monitoring folks may be pigeonholed as reactive find and fix services. But really how we break that is, again, going back to that shared reliability goal, which is identifying our strengths, right, of all the departments involved, having that unified purpose and operational synergy. I like to add that on the side of this slide, the four essential components that I find leads to that success is number one, diverse expertise, clear objectives, the collaborative environment, and most importantly, in my opinion, is leadership, having that effective leadership in our plans. And this is a biggie, last but not least of those four that I wanted to touch on is lack of documented standards. If there's one slide that you really want to listen to me hammer on a little bit today, it would be this one. Again, we're reverting back to the first couple slides, that graveyard of ideas. Well, when you look at what the average tenure for plant managers, reliability engineers, currently is anywhere from 2 to 4. I've seen some statistics say 1.5. So when you break that down and you look at it, how do we ever successfully implement anything within our plants, right? So if we look at this, we break that down. New leadership arrives. We've all seen it. New leadership arrives and initiates a fresh plan, whether that's some of those plans were on those gravestones. And when that happens, standardization is bypassed. Again, reverting back to those short-term fixes that we spoke about. And ultimately, that leader departs, right? You're looking at that 2 to 4 years, that leader departs before the program is institutionalized. Next person comes in, starts that cycle all over again, right? The cycle repeats, leaving our organizations in just perpetual mediocrity. So for me, none of this is simple, right? You got to put in the work. The standards got to be there. And the way we do that is three things I want to touch on: implement, improve, and sustain. So when we talk about implementation, we talk about standardizing procedures to survive personnel changes. I'm going to hit that again. Those three words: survive personnel changes. Improve, use a baseline to measure and refine performance, and ultimately sustain. Again, ensure reliability is a process, not a person. That's the key takeaway here. Make sure your program, your reliability is a process, not a person. To do that through these documented standards so it can survive those turnovers. So I'm going to pivot here just a little bit. I think it's important that as we go on today and talk about how to bridge that divide between reliability and condition monitoring, that we first kind of define a couple terms, right? Reliability, I think, is a term that gets thrown around and used in different areas. So before we dive deeper, I just want to define those two definition. So reliability, as we know, refers to the ability of a system to perform its intended function without failure, right? For a specific period of time, under certain conditions. And maintainability describes how easy it is to fix the system when it does fail. So we need to remember that reliability, in its true sense, is designed in, and maintainability is a design attribute. So remember, moving forward, improving reliability, because we always talk about reliability. You see it a lot in our side of the world, right? EMISA, condition monitoring, people talking about improving reliability this and reliability that. But in the true sense, improving reliability really requires redesign or replacement with more reliable components. However, the point that I'm talking about today, however, we can greatly influence, right? We can greatly influence or impact that asset seeing its full life cycle. By doing the right things. And once we close that gap between our condition monitoring, reliability, engineering departments, we unlock tremendous benefits. So we're going to talk about how you will see these impacts in both maintainability and reliability, resulting in a positive shift in the KPIs everyone's loved so much. You see that out there a lot, even in marketing now, KPIs coming in. However, not going to beat KPIs to death. I'm by no means an expert in them all or at all, but I'm going to briefly discuss two of them today. If your company subscribes to a reliability mentality, you most certainly have heard of OEE. You may have even been beaten closely to death with this at some points. It's described as a gold standard, right? So if you're a reliability person, you know this as a gold standard for measuring manufacturing productivity. I'm not going to read through all this. We're not going to make this an OEE or KPI seminar, but OEE measures three factors, right? They're on the far right side: availability, performance, quality. I think this is a great slide that I put together. Again, you can take a look at this when EMISA sends us out and take a little more deep dive into it. In my opinion, when I'm talking about trying to get condition monitoring and reliability engineering and operations and stuff to try to collaborate, and that's going to be the key word. The main word here is collaboration for this seminar. Is there's two metrics I really like: OEE and maintenance cost per unit, I think, for what I'm trying to get across here. So let's keep moving. So with this, I'm just going to go through the slide very quickly. Correctly applied OEE measures should foster cooperation and collaboration between operations, maintenance, equipment engineering to identify, reduce, or eliminate the major causes of poor asset performance. However, maintenance, operations, engineering, condition monitoring teams working alone, this is the key point, working alone cannot improve this metric. So again, the takeaway of this slide is not so much OEE as much as it is, you will never achieve any of your KPI goals that are out there without collaboration of all the teams involved. This again is another one I found very interesting that I took from Trent's seminar on what he calls a cycle of doom. I highly recommend you go take a look at it out there if you can find it. It very nicely puts there, it shows increased OEE doesn't always equal producing more units, right? So it's easy to fall in the trap of manipulating numbers by changing what you're measuring. And where I'm going with this is don't focus on, as I say here, don't focus on hitting a number, focus on performing the correct actions, right? So if we want to hit those green metrics, how do we do that? Well, first off, by being honest, right? We need to be honest and realistic in our goals. And a term that you've probably heard more and more by several of us in industry is be brilliant at the basics, right? We need to start at the basics and we need to do those well. Because if we don't have the basics, we can't continue to build on that. And as my good friend Howard said the other day, I heard him say, a foundation built to sand will not sustain a program very long. And that is the absolute truth. The other metric I wanted to talk about and how we're going to and you'll see, as we move forward, how we tie all this together is maintenance cost per unit. And this KPI I think is great because it measures the total expenditure, right, required to maintain assets relative to um, the total output. So whether that's units produced, miles driven, hours operated, right, over a specific time. And this one simply um, typically includes labor. So, anything like wages for technicians, contractors, materials, right, spare parts, lubricants, consumables, overhead, your software, your tools, your licenses, your specialized training. So when we look at this one, we aren't just looking at how much the maintenance department spends. We are looking at how effective those dollars are at driving production. So if our costs stay flat, but our reliability drops, obviously our MCPU will go up and vice versa. So it focuses on, or excuse me, it forces us to stop looking at maintenance as a cost center and start looking at as a capacity provider. This is probably one of my favorite slides in the presentation. It really hits home and makes us take an honest look at our programs, right? So we're going to run through these very quickly. I'm going to start off. This statistic that I'm going to give you now is one of based on my opinion of what I've seen of being in the field, running reliability and condition monitoring programs for almost 3 decades now, and I believe that roughly 80% of condition monitoring programs that I've walked into or helped revamp, if you will, fall into that find and fix trap that we had talked about earlier in this. So what I mean by that is these programs successfully detect faults, and that's where it stops. They stop short of investigating the why by taking that data and saying, why? Why are we seeing this? Is this just a routine thing, or is this an ongoing problem? They just stop short of that. They're happy that, hey, we found this. We can now replace that bearing and we'll move on to the next thing, right? But they don't investigate the why. They don't perform the root cause analysis or change the design that I was talking about in the reliability when I was given the definition. We don't change the design or the environment, right, to ensure it doesn't happen again. Very surface level. We don't move in, those programs do not move into the defect elimination realm. The hero culture, this has been a problem forever, right? Maintenance teams are often rewarded for how quickly they fix a broken machine. Let's be honest, that's how a lot of us operate, rather than for the fact that the machine hasn't broken in 3 years, right? Forever fixing, not forever fixed. And that comes from a lack of collaboration. Resource constraints, well, let's be honest, root cause analysis takes time and brain power. And when a team is buried in backlog of work orders, or they're putting out fires and chasing their tails all day long, you know, they only have the capacity. Our teams only have the capacity to swap parts, not study them and improve them. Again, the biggie here are organizational silos. Well, as I had spoke about before, condition monitoring can be seen as an inspection task, while defect elimination is seen as an engineering task. They don't work together. It's like, hey, here it is, do what you want with it. Again, never moving forward to an ultimate solution with that. So without that bridge between them, the data never leads to a change in design or procedure. And my favorite point here, data overload. If you spend any time on LinkedIn or anywhere else, I mean, marketing rules the world right now. So all you see is data, data, data. Which is data is good, it's needed, right? But many programs focus on collecting data, whether it's vibration, oil, thermography, whatever it is that you're doing in your plants, but lack the analytical layer, right? To turn that data into a bad actor list for, let's say, RCA. So as I like to call it, data rich, insight poor. Why? Well, why defect elimination? Well, it improves our product quality and reliability, right? This is where we want to be operating. Um, as I got written here, it's a systematic process of identifying, investigating, and removing the root causes of reoccurring problems. And we all know how much our plants can be plagued by reoccurring problems. But again, going back to, do we have the time to design that out and look at that deeper? Do our departments even collaborate on that, right? That's what we're talking about. How do we do this? Well, we achieve it through, again, like I said, through systematic root cause analysis and implementation of corrective actions. And I believe who's responsible for that is everyone from operators, maintenance teams, production staff, the reliability group, the condition monitoring staff, management to do what? Again, the common denominator here to collaborate. We need to collaborate more. And this is really defect elimination. This is really where you want your teams to be operating, right? So, case in point, just a little statistic here: world-class plants spend roughly 20% of their time in the realm of RCA and defect elimination, where average plants are operating in roughly 5% of their time, focusing almost entirely the rest of their time on execution of repairs. I added this one kind of last minute. I was asking Amissa, earlier before we started this. I'm like, hey, I can't stop. I got this thing. I can't stop adding things. There's more I want to talk about here. This is one of them. Aligning condition monitoring long-term reliability goals, right? So connect CBM to defect elimination. I know I'm beating that to death. Integrate value across your environmental health and safety, your ops, quality, engineering, right? What I can say about this is reliability cannot live in a silo. Sustainability is only reached when operations, maintenance, and all those teams use asset health data as a shared single source of truth to drive collective ownership. So this is a biggie. Make it a strategic driver, not a standalone effort. So now we're going to start getting into the solutions. How are we doing on time? We all right? All right. So how do we bridge the gap, right? Well, and honestly improve those KPIs that I was talking about and ultimately contribute to defect elimination. Well, we start right here, right? Identifying core commonality of our departments, which should be optimizing the performance and lifespan of physical assets. So let's look at how we achieve that by getting into the solutions. I just quickly threw this together, what I call the organizational excellence pillars. Again, leadership. We're gonna talk about what we can change there. We're gonna talk about changing communication, our teamwork habits, building out our documented standards, and ultimately leading to a plant-wide reliability mentality. So leadership, back to that. First and foremost, tear down them silos. We got to get rid of them. Actively break down departmental barriers that hinder data flow and cooperation between everybody. Get to that unified vision like I had on that last slide, right? Align. Well, we're just talking mainly about our condition monitoring reliability team. So align both those teams under one objective, right? Optimal system uptime. Reliability cannot exist without condition monitoring insights. And the reliability team taking that, collaborating, and making the improvements. Strategic investment. Leadership isn't just about guidance. It's about providing the tools. Again, if we don't have those tools, we don't have the technologies provided, we don't have the training, or more importantly, the education to keep building our people up, we're not going to be able to retain them. We're going to be in that constant cycle of constantly looking for more people. And let's be honest, training isn't cheap. It takes time, it takes money, it takes a lot of effort to get people up to speed. So leadership needs to understand the importance of investing in their people and the tools that they need to perform their jobs optimally. And open the channels, right? Facilitate regular high-level interaction to ensure the data informs the reliability strategy. So I put this on LinkedIn when I was posting this the other day is a statement that I said, great leaders don't just manage departments, they manage the space between them. If our condition monitoring reliability teams aren't talking, you aren't running a reliability program, you're simply running two separate silos that happen to work in the same building. All right, let's improve our communication. Let's get speaking the same language. Seat at the table. This used to drive me crazy in the field. You get called in, I'd get called into a tissue mill. We'd find let's say a $30,000 100-ton Yankee dryer bearing bad, and we'd have a meeting, and there'd only be a handful of people in there. And I'm like, we really need to have not only just condition monitoring person myself, but we need to have some engineering folks in here, operations, all that, to collectively bring our expertise to the table to decide what our next actions are going to be. So this one's big to me. People need to have a voice. They need to have a seat at the table. So ensure your CM specialists, your maintenance, your reliability engineers are all present at all major planning sessions. Now, there's some of you probably laughing, saying, I don't need any more meetings in my life. Let's be honest, a lot of our days are consumed with meetings, but I think this is important. Everybody's got to have a seat at the table. Everybody's got to have a voice, which leads into the next point, right? Regular joint meetings and project planning, knowledge sharing workshops. That's huge. Don't let that knowledge just reside in a few people's heads, right? Because those people will be gone. And I've seen it. I've seen it time and time again where that knowledge walks out the door, and that can be devastating. To bridge those gaps, and the one thing I like to talk on, for those of you that know me, know I'm a big aviation guy. What I call the aviation standard. So, to put it kind of in a story, it's just like as pilots and air traffic controllers use a standardized language, right, and terminology across the globe, it's standardized and that's done to prevent catastrophe, right? So I always say, why should our condition monitoring and reliability teams operate any different, right? We need to develop a common technical vocabulary along with those standardized processes and procedures. Because honestly, checklists, the checklists that we all live and virtually live and die by in aviation are not a to-do list. They are lists that are a discipline, read, do, verify method. And so I always like to bring up that parallel and say, I think we need to take a page out of the aviation industry that way. So, anyways, seamless data exchange, move beyond just sending reports, right, to collaborative data interpretation. So, my speaker note on this one is simply miscommunication is a silent killer of equipment. We need to move from here is a report to here is shared insight. Right. So again, everybody needs a voice before the failure happens, not just during the post-mortem when everybody's in there pointing fingers. All right. Teamwork and cross-functional integration. So shared metrics and KPIs, right? Again, reward the team based on outcomes rather than individual firefighting or reactive maintenance heroes. Cross-training initiatives. I've seen this over the last 20 years try to be implemented with some pushback, right? Mechanical folks like to stay mechanical, electrical like to stay electrical. I think it's come a long ways, but just not having to do each other's jobs, but having understanding is the key to understanding what each department's doing. Joint analytical processes, right? Collaborating on RCM, RCA, FMMEA, all that stuff, and having integrated dashboards. Everybody loves dashboards nowadays, but I think you can keep them simple. You can keep them relevant with a single source of truth, right? Where that CM data and the reliability strategy reside. So let's keep moving. Documented standards, as I like to call it, the proactive shield. Let's be honest, sustainability means making this program again people-proof. So to survive leadership changes and staff turnover, reliability must move out of, like I said prior, it's got to move out of individuals' heads and into our documented standards and make it daily habits, right? So by integrating this stuff, we ensure this culture becomes a permanent bedrock of the organization, not just that program of the month. We don't want to end up back in that graveyard. But a sustainable way of operating that persists regardless of who's in the seat at that time, right? So I'm going to run through this because I think this is a very good slide. Precision versus close enough, right? Shift the focus from merely fixing to achieving precision tolerances, whether that's precision alignment, balancing, can extend asset life 3 to 10 times. My vibration nerds in here know that we try to push the importance, when we try to sell a program to our management and stuff, that it's more than just finding and fixing. It's about setting those standards and being able to, when our vendors come in and say, hey, here's a pump skid, here's a 1,000 horsepower motor or whatever, to be able to look at our standards, test that, and say, yes, we're going to accept this or no, or not, right? Establishing the golden rules. Rigorous standards for alignment, balance, and vibration. standardized acceptance testing, like I just talked about, and ISO compliance, if that's what you want to use, and unified, such things as unified installation and startup practices. Criticality analysis, again, I think that should be something that's done jointly to determine which assets deserve the most focus and ultimately creating your benchmarks based on that, right? Identifying and adopting industry best practices to move from that good enough to world class. So we're coming up here on the end, just a couple more slides and we'll open it up for discussion. But what I like to call the reliability mentality, right? Um, it's got to be a cornerstone, not a program, a permanent mindset, not the flavor of the month, right? We need to have defined roles, clear responsibilities, coupled with a shared commitment to asset longevity. And the ultimate goal is to transform our plant from a repair shop to a high performance reliability engine, right? So we need to reframe some of that stuff. The goal isn't, again, the goal, folks, if you get anything, the goal isn't to get better at fixing broken machines. It's to eliminate the defects that drive failure. Again, are we forever fixing or are we forever fixed? And once you answer that question, that answer defines your culture. And to me, as I like to say, yes, I am in the condition monitoring business. I am in the solution business, but I will tell you this, the most advanced sensors in the world and the most precise data in the world cannot fix a broken system. Again, going back to my main point of being brilliant at the basics and having the foundations, right? Reliability is not a software package or a tool. It is a culture of collaboration. And by committing to that shared vision and breaking the functional divide, again, we're not just moving those KPIs that I talked about earlier. We're building a legacy. We're building a legacy of excellence within our plants that will outlast the next cycle or the next leadership change. And that's what we need to do. Otherwise, again, we just keep sitting in that hamster wheel of, okay, next person up. What's he or she going to want to do? What's going to be that next flavor of the month to get our plant running tip top? And lastly, collaboration. Again, just I've been beating this in our heads this afternoon, but collaboration is the glue, right? Reliability, condition monitoring departments, sharing that core commonality, like I talked about, optimizing performance and lifespan of the plant's assets, getting into defect elimination, um, getting our leadership where they need to be and doing the right things, having the proper communication, teamwork, continually building on that teamwork, understanding what everybody's doing, so we can ask the right questions, bring in the right people at the right time, get those documented standards and best practices and processors, and foster that reliability mentality, right? So again, cross-departmental ownership, shared goals, data's got to move through the entire reliability system. So again, effectiveness on that all is collaboration, clear communication, defined roles and responsibilities, working together, we can really move into and ensure a smooth operation of ultimately what we all want, which is maximum uptime and extended lifespan of critical assets. So I'll just leave you with these closing thoughts slide, and I'm going to turn it back over to Amissa for next steps.
Thanks, Matt. Okay, next slide, please, Matt. All right, so we're going to get into Q&A in 1 second. I just want to go over a couple things. One, if you're wanting more information about the webinar or have questions about it, we are going to send out the recording afterwards. So you will get the recording of this webinar if you want to go back through. If you have any other questions about what you've heard in the webinar or something pique your interest, I put our email addresses in the chat there. So feel free to email either one of us with any thoughts you may have, or if you are interested in our services, you can contact us as well. And just so you all know, we love putting on these educational webinars. Uptime Solutions is a condition monitoring company, so we do offer condition monitoring expert services plus the product of our 3-in-1 wireless sensor, which measures ultrasound, vibration, and temperature. And real quick, just as a plug, we do offer a pilot program. So anyone wanting to try it out, we offer 60 of our sensors for 60 days for a flat $2,500. And we do the installation and we're working as your partner the entire time during the pilot. So just have to do the plug because we are a company that sells wireless condition monitoring. But we do appreciate you guys coming and hanging out with us for these educational webinars that we put on. Now we're going to get into Q&A. So if you haven't already, if you have any questions, type them in the Q&A or even the comment section at this point, and we're going to go over those. So Matt, do you want to hit the next slide? And then I think we already have one question that I see here before we hit the ones on the slides. I actually really like this question. The question is, thanks for the presentation. I would like to know what is your opinion about how AI will and can be implemented in predictive maintenance? Um, I will start out before I pass it over to you, Matt. I want to say that the reason I love this question is because AI is such a big thing in so many different industries right now. And at Uptime Solutions, we take kind of like a moderated approach to AI where we see the benefits and we know that there's so much potential with AI, but we also want to be realistic and grounded about what the limitations still are at this point for our industry specifically. So given that, Matt, like you've been in the industry a long time, you've seen a lot of different products and softwares and you know how AI is being worked into condition monitoring and predictive maintenance. So what are your thoughts about one, how AI could be helpful and maybe like what its limitations are and how that feeds into predictive maintenance plans?
That's a great question. I've been kind of outspoken on it, both pros and cons of it,
Hmm.
for the last few years. I'll start by saying this: when there's several of us old heads in here today, I seen some of the names on there and stuff, guys I know, men and women who've been doing this a long time. And as we know, nothing has changed quickly um, in this industry historically. You know, when many of us started, there was maybe five, six different condition monitoring, what I call legacy condition monitoring companies out there who provide the analyzers, the online stuff like that. And they were kind of around forever up until about 15 years or so ago when we had the Wild West kind of happen, explode. And now we got, you know, 200 different wireless sensors out there and different solutions and different things. And now the AI boom is jumping on that as well. So I will start off by saying this: it's a really exciting time to be in our industry. There is a lot of neat stuff out there. We can get information very quickly. We can get a lot of great information. We can also get a lot of very bad information, right? That's part of it. I think as condition monitoring experts and reliability experts, the human side of that is we need to be able to differentiate that, right? Good data from bad data. We need to ask the right questions. We need to vet a lot of this AI stuff that's out there and say, so when you see, I think a lot of the marketing out there can be disingenuous at times or misleading. You see a lot of folks saying, and not just in condition monitoring, but anything saying, you know, we got 8 billion points that are AI or algorithms or machine learning, whatever buzzword you want to use, is trained on. And I often say, well, you know, what does that look like, right? Is it trained on points that might not have been running? Is it trained on, you know, are we always comparing apples to apples type of thing? I think AI is great for quickly going through data. That's where I trust it a lot right now. And I think it's a great tool to quickly go through data and look for any type of alarms that may have been set. I mean, again, for us nerds in the group, you ask 50 vibration analysts how they run their programs, and you very well might get 50 different answers, right? Some use alarms, some don't, that's just how it is. But I think AI, when set up correctly, is good for anomaly detection and very quickly be able to help an analyst be more efficient that way. I'm not sold yet at this time that I'm gonna, again, being from Wisconsin, I pick on the tissue industry, pulp and paper. As a paper maker, I'm not gonna at this point allow an AI system to be sold an AI system under being told that it will um, monitor, flag, and give me exact determinations of like how long it's going to last, different things like that. I think there still needs to be that human interference or in there. So I don't know if that answers the question. I think it's gonna keep increasing. I think we will eventually get try fast and hard like limitations of it in our industry. I'm still waiting to see how it trains itself and pans out on very process heavy industries like pulp and paper and others out there where it might struggle to train because it might not see some of these different things for a very long time. So, like I said, I'm excited for it. I think it's exciting, but I am still kind of treading lightly with it. But I think as far as making people efficient, making things quicker, yes, I think it's great.
Thanks, Matt. Um, and then um, I'm like to piggyback on that. Like, how do you think AI is actually can help with predictive maintenance? Is it just to clarify that? Are you saying that by being able to go through data and give alerts, it can help inform predictive maintenance programs more efficiently?
I think it's going to help the analyst, right? I think
Okay.
it'll help the analyst when it's tied in correctly to be able, especially those of us who are looking at tens of thousands of data points a week, right?
Yeah.
Whether that's large in-house programs or those of us that are outside contractors who every day are going through major facilities. And let's be honest, I mean, it's time consuming, but once it's set up right, right? That's the biggest thing, like I said before, garbage in, garbage out, like we said about computers how many
Mhm.
years ago. Same thing with AI, right? We got to make sure that it's set up properly and that there's still a subject matter expert behind it to verify that it's not drifting or doing it, something else. Because that can
Yeah.
as we know, like I said, picking on the tissue industry, that can very quickly turn into a very expensive drift.
Yeah, okay.
But
And I think like from what I've seen and heard from many people in the industry is that again, kind of to echo what you're saying, that it is great for um flagging something, but
Mhm.
but really the AI doesn't understand the operating context of the equipment. It doesn't understand the environment, right? And then having that um person who is an expert and who has worked in the industry and understands those things, review all of it, and then having them be able to give a very detailed prescriptive maintenance recommendation, right? Like that's something that I think AI cannot do at this point that a human has to do,
Yeah.
if you want it done well, that is.
And I'm certainly not all like doom and gloom about it. I think it's great.
Yeah,
I think it's going to keep evolving. You ask me the same question in 5 years, I guarantee I'll give you a different answer, right?
yeah.
Um,
Mhm.
just at this point in time, I'm still a little not hesitant, but I'm not like pushing all my chips to the table with it.
Yes.
I think it's definitely got a place, but like you said, on the processes and different things, I think over time, it will be able to figure it out, but
Yeah.
it will take time.
Yes. Agreed.
Not, it's not like scraping the internet for, hey, how do I figure out it? Find me the formula for an interrace bearing defect, right? Where it can just quickly scrape the internet and give you all the information that you need. Uh,
Hmm.
so
It's not
we,
always accurate though.
we could
The
talk for
information
days.
that comes back. So that's
We
why
could
it
talk
takes a
for
real
days, and I'm
person.
sure if we gave everybody a microphone today in here, we could all debate that too, right? But time will tell.
Um, okay. Let's see. I think I saw. Oh, okay. Another question is, based on your experience, what are what are the benefits between like doing manual condition monitoring, like route-based condition monitoring versus, wireless sensors or continuous monitoring?
I think it's kind of a case by case basis. I came from the route-based world. I will
Mhm.
always be a fan of route-based analysis. I remember when wireless first started coming out, and a lot of the folks out there were talking about, especially around COVID, hate to bring up the C word, but like, hey, there's no more analysts left. Hey, if this stuff goes on, we're gonna have to do this remotely. Um, again, I think there was a lot of disingenuous marketing there. I think there's always going to be a place for it. Because somebody's going to have to go out there and do more more in-depth diagnostics, right? You're going to have to be familiar with an analyzer. You're going to have to be educated. You're going to have to be trained to go out there and do that. That's one point. I know that's not answering the question completely.
Mhm.
But I think if you have a robust in-house program, I think having a route-based program is great too, because you're walking around, you're touching, and this might just date me and make me sound old, but you're touching, you're smelling, you're seeing, you're identifying a lot of other things, whether it's oil leaks or you're hearing a bad coupling in the distance or something going on, right? I think route-based certainly has its place, and I also think wireless has its place. And I always, those that have been to my session of a hybrid condition monitoring, um, in that seminar, I tie those two together. They both have a place, and I think well, all three, right? Online, route-based, wireless, I think, or continuous monitoring. I think if you bring those in together and you do it correctly, you can do it very affordably, and you can really create one hell of a program when done correctly. I think just going into something uh, and just scaling something up, or let's be honest, a lot of the corporate initiatives around Industry 4.0, digital transformation, all that has really pushed a lot of wireless technician technology and things like that without really people jump quickly and scale too quickly without looking at it and saying what makes sense here, right? Hopefully that answers the viewer's question. But
Okay.
I think the best approach is a hybrid.
Okay. Yeah. And I was thinking too, when you were talking, budget is probably a thing too, like route-based, depending on your situation, maybe a little less expensive. However, you're not getting as much data and you could have a failure between when the route information is taken. So I think that's one thing that comes to mind when I was listening to you talk.
Yeah,
Uh,
that's why I say there's got to be collaboration a lot of times. Like,
yeah,
how often should we be checking this? Do we need like a real high-end triggered system, for a protection system or something like that? Or do we
yeah,
need something that's going to a nice wireless system that can snap two readings a day to make sure that we're catching everything, or a route-based thing tied into other activities as well, right?
right. Like asset criticality also probably plays a part in that, right? Like if you have
Absolutely.
mission critical assets, you want to be monitoring those in as close to real time as possible.
That's exactly
Um,
the point, and that's where
if
that
it's not,
collaboration
then you
comes
could do route based on them, right? So
in. Right.
yeah, you can do a combo there. Okay, do we have another one? Oh, yes. Nathan just said the same thing I just mentioned, which is criticality analysis based route or wireless condition monitoring. Yes.
Absolutely.
Um, all right, let's answer this question here. How can you tell if your condition monitoring program is actually preventing failures rather than just detecting them earlier?
Well, that one simply, I go back to what I was talking about with defect elimination, right? So if maintenance teams are when you finally see your maintenance teams no longer being rewarded for coming in at 1 a.m. For how quickly they fix a broken machine, rather than, hey, we're celebrating, like, this machine has been a pain, has been eating our lunch for the last 10 years, and we took the time to look at this, we took the time to get that right, the right data, to bring in the right people to do the right diagnostics. And now we either engineered that out, or what have you, right? And now we're celebrating that, hey, we've got like an extra 5 years of runtime on this asset.
Mhm. Nice.
That's when you know that your monitoring program is actually preventing failures, um,
Okay,
rather
that
than
makes
just
sense.
detecting
That
them.
makes sense. And then let's go to the next question. I think we have
I think we had one
a
other
couple
one
more
that
minutes
came
to
in.
go over the next question.
Sure, let's do it.
So, which metric do you think is the most underutilized when trying to improve reliability? OEE, MCPU, or is there something else?
And again, as I stated, there's a lot of, as you know, we have a lot of friends in our circle that spend a lot of time on metrics and different things in their professions. Um, and you can get a lot of different thoughts on this. I will say, like I said, OEE is the standard bearer, right, on on the plant floor. But I think it suffers from a couple major structural flaws. Um, if it's used in isolation, meaning, again, plants this is a good question because it will probably clarify what I was talking about a little bit that I went a little too quickly through was that plants will frequently game OEE targets, right? By adjusting the targets, the theoretical targets like speeds, changing shift definitions or ignoring short stops, things like that. Whatever. I'm just pulling things out of the air. Um, I mean, you can always game the system and achieve that impressive 85% OEE, hypothetically simply by throwing endless overtime, right? Expedited parts, contractor dollars at a machine, whatever. But it does tell you if the equipment ran, right? But not at what cost, um, to keep it running. I like maintenance cost per unit. This was explained to me very well, um, by another industry friend, and it's the most underutilized metric because it translates that physical asset health directly into good product margins and let's cost of goods sold, right? So most plant leadership uh, views maintenance as a static overhead, right? Line item to be trimmed during budget reviews, where I think this maintenance cost per unit shifts that conversation, or at least helps shift that conversation from uh, how do we cut the maintenance budget to, well, how does reliability lower our cost per unit manufactured?
Yeah. And I think that's important because then maintenance can be seen as a revenue contributor versus a
Right.
cost center for the company. So I think that's key for to be recognized as that uh, overall.
Absolutely.
All right, everyone, we're up on time and we really appreciate all of you that were able to join us. Again, we'll send out the recording after this and stay tuned. We're going to have more educational webinars in the future and we love having you all join us.
Yeah, we love being with you guys and thanks for joining us and we look forward to the next one. Again, like Mrs. said, if you got any questions or want to continue discussions, just reach out.
Mhm. All right, thank you guys. Have a good day.